if you're going to factor this, there's no numbers that are in common here, but there are x's, right, on both terms. So you're going to pull that x off. So when you yank that x out, you'd still be left with 6y, wouldn't you? And what would you put in place of that x? Put your 1 there like a placeholder. 1's a good stand-in because 1 times anything is itself. So that's why you put a 1 there. And that's it. That's all you can do. This is called factoring the GCF of a polynomial, the greatest common factor of a polynomial. So this is the GCF. That's what this thing this section is talking about. So factor the given polynomial by finding the greatest common monomial factor and rewrite the expression. Most of the time we just say factor this. Most of the time what happens. So let's try to factor this guy. 25xy minus 10y squared. So you look at the numbers first, right? You can't pull a 10 out because 10 doesn't, but you can't pull a 5. And you can pull a y out. See, that's got a y squared and that's got a y, so pull your y out. That's right. So you've already got the y's, so that doesn't matter. There is an x left. And you got a 5. So 5 times 5 and then an x gets you 25xy. This times this gives you that original. What would this other guy be? Negative 2y. And remember, you can always redistribute it and get what you started with. So if you redistribute, you wind up with 25xy. Redistribute, you wind up with 10y squared. So you see why I threw this on top of this. I don't like to throw a whole lot on top of divide by the division algorithm, but this is not too bad. I don't think this is too bad. So let's see. I'm sure it gets worse. I guess the only way to make it more complicated is to put more letters on it. That's not much more, that's not too bad complicated, is it? You can still take 5 out. What letters can you take out here? X and a Y. You got to take the smallest ones, right? So you got a 5. You already got the X, and you got 1 Y. So you need 1 more. You got 5 times 2, right? Gives you 10. You got an X. You need another one. You got the Y. You close her up. What do you think, Candy? Pretty simple stuff, right? At least it is right now. Yeah. Let's try this trinomial here. 35 plus 5x squared plus 10x. This is number 7. It's number 7 on our little packet here. So, what do all these guys have in common? They got 5 in common, right? But this has an x and this has an x squared, but this one doesn't have an x, so you can't do anything else with it. Just 5. So what would the first term be here? 7. And the next one? X squared. And the next one? 2x. And if you distribute a 5 through here, you get what you started with. Well, this isn't tough at all, is it? Let's skip over, let's do number 8 here. 5x cubed plus 10xy. Let me rephrase that. It might be tough if you didn't know your multiplication tables, wouldn't it? It'd be plumb near impossible to do. If you didn't know where to start, you just didn't know where to start. So you put a 5 in, right? 5 goes into all those. And can you pull an x out? Nope. Can you pull a y out? Nope, because it's not over there. So you're kind of stuck like that last one, aren't you? Let's see. Gosh, let's just do something just crazy tough. Let's do number 11. Let's just go for the glory. 10x squared plus y plus 25x squared y cubed plus 5x squared y to the 4th. You check the numbers first. Fives, okay. Now I'm going to go, well, I shouldn't have done that. Okay, now what about the letters here? You get an x squared on all of them, don't you? And what about these y's? Just the y. Now I'm going to start my parentheses. Okay, I've got x squared already here. So I don't need these x squareds anymore. But that would be what, 2? Just 2, isn't it? You've got your y already. You got the x squared, you just need a 2. This needs a 5. And you need a y squared. That's already got a 5. You got the x squared. Just need cubed. Yep, cubed. I put squared. It should be cubed. Good call. Yeah, don't. Yeah, you see me up here changing the problem and stuff. It's like, I'm always right. No, I'm not always right. That's what my wife says, at least.